So, thank you everybody for coming. I am pleased to introduce you to Sanjeewa Narayana, who will be presenting an AI-powered platform connecting researchers and farmers to genetic insights. Sanjeewa leverages AI in digital agriculture to help researchers and farmers turn genetic data into actionable insights. So, please join me in welcoming Sanjeewa Narayana. You're muted.
Thank you, Melinda. Hello, everyone. My name is Sanjeewa Narayana, and I am an independent software developer working in University of Guelph. I just want to showcase my platform for everyone, which is based on RAG-driven AI platform. Uh, so my goal today is to show you using advanced AI, not just a chatbot. So it's gonna when you ask questions, so then it will give you like context-aware answers. So yeah, so moving on. So what will we demonstrate today? So the goal is to showcase advanced AI drive scientific and agricultural outcomes, and then our introduction to Emilia, and then I will walk you through like how it works. Um, so before I get started, so let me tell you the stories. Before I start building this, so I spent years managing IT and networking infrastructure across 10 research stations. So my job was to help students, researchers, and researchers building data pipeline and collecting data, and also like helping budget, like helping to do budgeting in terms of like technology. Um, so I was the guy in the server rooms, like who spin up a virtual machine for a student if they want to do some analysis or collect the data. So yeah, so moving on to now next slide. So then I like when I work with the researchers, then I understood like there's a gap like between farmers and the researchers. So the researchers are more aware of the knowledge, but the farmers are not that knowledgeable in terms of like the researchers. So I was researchers like burn hours like fighting with data storage or manually organizing papers, often giving up on promising technologies. At the same time, was like I saw farmers like entirely depending on uh, intermittent advice from like vets or maybe like some um, advisors. So they're depending on that one. So then I thought like what if we have a solution um a solution between the farmers and the researchers. So, like what if I could build a solution that connects like the expertise from the researchers with the the latest literature, and like if we can connect those into like lab data or like the farm data, so then we can get a like good insight based on that one. So the researchers struggle. So then. And in my time at the stations, I saw like so many researchers. They were doing like different kind of research, and then they will spend a lot of time spending like collecting data and kind of things. But sometimes they spend like less time on analyzing data, or maybe they will go with the the like a traditional way, or they'll collect manually data and analyze. Like they'll use like maybe R or any other software to just run some analysis, but they will not go in depth because of the um, technology burden. Um, uh, so 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 on the other hand, when you talk about the farmers, then they depend on like external experts, or maybe like there's like in like a decision making. So like they will have to wait for someone to advise them or some kind of thing. So like if we have inbuilt solution, so then that will be helpful for them to take a decision immediately. So I saw that one during when I was working in research stations. So this is the Emilia AI. This is like the that's just an overview. So I can show you. So let me. So this is the Emilia AI. So which is connected to DAG. Like this is external thing. So it's not built yet. So this is the idea. So and it is connected to genetic and genomic database, and then it will fetch all kind of data like into Emilia AI. Also like Emilia AI is powered by LLM. And also like with the publicly available journals APIs. So this is like so my uh, like so there are like so many um, analysis tools that is used by geneticists today, so such as like a P-Link, BluffF90, and other services. So what if we can like integrate all those tools into Emilia AI, so then it will provide like then they don't have to spend so much time uh, analyzing themselves because there's a big learning curve. Like if they want to use these kind of tools, so then what if we automate that one? So then they don't have to spend time learning specific packages. So that's a base thing here. Uh, okay, so Kevin, can you explain a little bit?
Yeah, so hey everyone, my name's Gevin. I work as a software developer for Warner Brothers, like the movie company, although a lot of my work isn't in that kind of realm, it's under CNN. So in the real world, I do have a lot of experience when it comes to LLMs and AI models and how they work in kind of a production or real world environment. So when it comes to this prototype that we have for Amelia AI and a lot of the genetic research component of it, the first important thing is picking the correct model. And there is no shortage of models nowadays. We have tons of new models and there's only new ones popping up every week. So for this one, we chose Chat GPT or GPT 5.1, which is the model behind Chat GPT. And the reason we chose this one is because it's very strong at reasoning across long, complex documents. So when it comes to genetics and agriculture, you have tons of research papers, trial reports, genomic kind of reports too. So you want the correct model that can handle a lot of that input, and it's able to summarize it, it's able to understand it, and also transform it as well. So GPT 5.1 works across a lot of good domains, even like economics, animal health, um, and agronomy. So another thing is like there's a lot of journal papers, and we needed to pretty much take in all the input and create a good response out of it. So GPT 5.1 is really good for that. And the way you can think about it is it's the general brain for this whole prototype, like the backbone, and we're only providing it with the input data. So we're telling it what to think with, but it handles itself on how to exactly do it. And it's definitely the best one for this use case. Next slide. So taking a step back and peeling the onion, there is another approach to this where we have to think about cost and operation when it comes to a model like this. And especially when you think about the real world, you want to think about as this application grows, how do we want to handle that, right? And how does that handle logistically? So when you have a model like this, like GPT 5.1, you don't want to self-host it. That's gonna You're gonna run into a lot of problems there, and most companies don't do this nowadays. One of the things it's gonna cost you a lot of GPUs, and GPUs are not cheap at all. And you're gonna have to require a whole like server farm full of them. If you ever seen those Bitcoin warehouses, you're gonna look at something like that in the long term if you are trying to self-host this kind of application. Another thing is you're going to need a lot of monitoring, a lot of scaling, security, a lot of resources to put towards it. So it's a really big operational load. And it's going to pull a lot of time and money away from the actual genetics and farm research, which is really where you want to put the time and money, right? You don't want to worry too much about the infrastructure of the actual model. So the practical decision to take here is to create a RAG agent, which I'll talk about in the next slide. But the good benefit of this is that it'll run by itself. It's really low infrastructure. It's low maintenance cost. It's also really easy to update if you want to add more data sources, or you don't have to, kind of build it from scratch if anything updates or anything changes. And a lot of the answers that it gives are actually grounded in evidence. It's not the model guessing, which is a really big problem with a lot of these LLMs. You don't want hallucinations, and you want it to give you the correct answers with the correct inputs most of the time, or obviously ideally all the time. Next slide. Yeah, so taking it back, I mentioned RAG, and RAG stands for retrieval-augmented generation. It may sound really daunting, but it's really not that complex. So pretty much what RAG is you have a large language model, or LLM, so you can think of GPT 5.1, and we just add an extra layer to that, which is a retrieval step. So what this does is that we give it a lot of input, like documents, records, anything we want it to reference as a knowledge source and as a source of truth. We'll give it to the LLM so that it can it'll look towards that first before generating a response. So you can compare this to like ChatGPT. If you were to go into ChatGPT and try to look up something, it'll give you the general answers. But if you try to go deep into research in a specific domain or topic, you'll realize it falls short. You get a lot of hallucinations. You won't really get the most up-to-date data. So this is why we add RAG. We add a retrieval step so that we can give it the data we want it to reference. And from that, it'll generate a good and accurate response. So we need this so that we get the correct answers, and their answers are always up to date. We have it specified for a specific domain because we can give it any domain specific data. And most importantly, this will reduce hallucinations because it won't make stuff up. It'll have everything we need to reference, and it will go off of that and use that as a source of truth. Next slide. So taking it even one step further back, I want to talk about why it's important to do cloud computing instead of, trying to run this on your own in your own machine, or even like a warehouse or something like that. So the benefits of the cloud, and in this case, we're using AWS, which is Amazon Web Services. You can access it from anywhere. It's remote. Anywhere you have an internet connection, you'll be able to access it. Also, if there's any new features or updates, we don't have to handle that ourselves. The provider will handle that. And especially with a LLM like this, they're always being updated. So it'll be a lot of infrastructure cost if we had to do all of that manually. And also, it's really good for collaboration. So if we have multi environments across the world, or even across countries or whatever, it's really easy to just set it up in the cloud and access it wherever you need to. And also, there's one other layer to this, which is infrastructure as code, or IAC. So this ensures that there's consistency across environments. It removes any of those issues where it'll work on one OS or one laptop, and then when you go to like another one, it won't work. You run into some bugs or issues. Having it on the cloud removes all of those issues, and it makes it really easy and manageable to scale and collaborate on. Next slide. And so if you think about the cloud, and even like any kind of production application, you really want to make sure there's three things. So you want to make sure it can scale, that it's always available, and that any kind of updates that happen in the future, like new phones, new technologies, you want to make sure that it can adapt to that as well. So when it comes to scalability, so that's growth, it can easily handle petabytes, if not even more, of data storage. And with genomes and agriculture, there's a ton of research papers, a ton of different data that you want to store, and you want to make sure it can store that, and then it can also access it. So for AWS specifically, we have S3 bucket, which can handle any amount of data, so we don't have to worry about that. When it comes to computing, we have a lot of different options. We have Fargate, for example, which will auto scale. So that means if we need to increase the compute, because if we get like a lot of users, it keeps growing millions, if not hundreds of millions, you can easily handle that. And especially if you add AI into the mix, you want to make sure that you have something that can scale along with that as well, because that's going to add a lot of additional processing. Another thing is the reliability. You want to make sure it's always available. And cloud infrastructure, regardless of, we had the Cloudflare outage and the AWS outage a month ago. It is still the most reliable compared to on-premises when it comes to reliability and uptime. So especially for like real-time farming decisions, you want to make sure it's always up, like it has a lot of good uptime. And also redundancy is another thing. Because if one region goes down, you want to make sure that there's another region. And a lot of these cloud providers, they have regions across the world at this point. So you never have to worry about if it's down in one part of the US, you can always connect to Canada or even somewhere in the Europe, like the database and all of that stuff. And also they have a lot of support for IoT, which is like Internet of Things, and in a lot of larger AI models as well. So you always make sure, or you always ensure that you're covering a lot of the use cases of any new technologies that come out as well. That's it. Now you're muted.
Okay, let me like explain a little bit about the simplified architecture of the whole platform. So like we have like a main server which has like two APIs, AI and research tools. Those like so the server is connected to the other resources, as you can see here, like PostgreSQL and DynamoDB for like chat preferences, and the other like S3 bucket for like storing data. Um, and like for example, so if the user, so this is the users, like users are the farmers and researchers. So then users will have an interface like web or mobile app, which is connected to the server. The server then will respond whatever the like then the server will respond to like whatever the client is asking, right? The client means the app, web app. Um, so yeah, so let me go on to the next slide. Um, so these are the resources like AWS resources like that we use for the this project. So we have like PostgreSQL, DynamoDB, S3, Neo4j, ChromaDB, and Lanche, like ChromaDB. Let me show you the actual resources that we're using for this project. For databases, we use DocumentDB, and for the computer containers, we use ECS. We have like two containers for that one, so the main backend and the user backend. So the main backend is like responsible for handling the internal database. The user backend is responsible for handling the user data, for example, like chat histories or the user profile data, or they have like some preferences, or those are things. So then, so there's like a two different like isolated databases, so they are not connected. So yeah, so the networking infrastructure. So we use a load balancer to handle the both backend and front end. Um, and we use AWS tool for like deploying and like like automating the deployment. It's like DevOps tools, but the DevOps platform is not available now. So then we will like implement DevOps like pipeline, so which will deploy all the commit to the GitHub automatically. So then it will be easier for the developers. So that's uh, the next one. So here's the proposed Emilia AI agent. So then the user will let me. So the user query a prompt, and then the application will take care of that one, and then it'll go back to the search here and looking for the knowledge burst. Knowledge burst is powered from like external APIs such as PubMed and Nature. So then you'll see like when we demonstrate, then it will show up the like a citation and other kind of things. So then it'll go back to the search and then enhance context and go into the LLM, and then LLM will respond with the context uh, result better than the um, general LLM, right? For example, like if you ask something from ChatGPT, so it will be like generalized answer, but in this case, then you'll get like a better answer. uh, Better answer, yeah. So this is the current workflow. It's the same. Uh, yeah, it's a current workflow. So user front end. So the user backend is developed using Bun.js, and the fast API is for the main backend, so the data backend. Uh, so these are the tools we use for the line chain. So there's a um like intent analyzer. So then that intent analyzer will analyze the user's request. So then it'll go through the external APIs and collect the relevant data. And then it'll like feed into the LLM, and then it will respond the answer. So these are the tool like orchestration, serializing. So the system supports natural language SQL. That means like the users can ask, like for example, if the user is a farmer, so then farmer can get like all insight based on the database that we have here for their day-to-day work. So that means the farmers and researchers can ask questions like count animal by sex, so we top 10 breed by growth, or so any kind of questions like that. A LangChain SQL agent interprets the query, generates the appropriate SQL, and returns a structured table, not just a raw text. So then also like you'll get an explanation underneath the tables, like those data can be used, and kind of things. Like you'll get like more explanation. On top of that, we added like data area summarization and the visualization as well. So if you ask about chart, plot, or like visualize the data, so then it will visualize the data. So then farmers can like like the mm, uh, general mm, like a regular dashboards, so they have like different plots and graph to showcase the data, so then people can get the insight out of that, right? But they cannot have like a customized version. So if they want something different, so they couldn't do that, they cannot do that. So that's why, so this will be able, like this tool will be able to help in that case. So like if you want to uh, plot or see some like visualize data, so then you can do whatever you want. Like if you want GeoS Manhattan plot, or maybe QQ plots, or like if there's like any statistical plots or anything, so that will be also generated. But the thing is, the database that we have today doesn't have like that much structured data, so you wouldn't be able to see the correct, not the correct, I'm saying like the uh, proper visualization you might not see because the lack of data. I would say like when you try the tools, and then you might like first see what kind of data available, and then you can go through it. Uh, so how Emilia AI help farmers? So for farmers, Emilia is designed to feel like a knowledgeable advisor, like I mentioned earlier. So instead of dumping tables, generic code, so then they will like the Emilia will give you like insight. So she translate everything into plain language, and very specific next steps. So how can like what can we do in the next step? So because the platform has access to farms own record in PostgreSQL and can generate visualization with Plotly. Farmers can ask for concrete views for the herd. For example, show me graph of test day milk weight for each cow for the last 6 months and highlight anyone below the herd like herd average. Emilia will query the genetic database and build the table and return a clear chart, makes those animal obvious. They can also ask more strategy questions like based on my herd and the current proof, which sires are best for improving fertility in this group of heifers, or given like animal health implementation history or any kind of data. So then it will be helpful for farmers. Um, one. So how Emilia AI can help researchers? So for researchers, Emilia is less a tutor and more of a collaborator. For it's not like I said, it's not like a general LLM. So she understands the internal genetic schema from the first grade SQL. So if you want to use the internal database, if you don't, then that's fine. Like you can do your literature your own. Like if you want to do some findings, so then you can do that one with the latest publications from our external APIs like PubMed and Nature. And that means the researchers can say something like run PGA on a growth and carcass trace for the cohort and show me clusters by breed. So if you want to like analyze the internal database. So in this case, like one other thing is that we can give users to access like upload their own database or connect their own database or dataset. So the based on that one. So because we like the system is powered by the RAG pipeline, so they will get a better answers than a general LLM. Uh, so the agent uses a hybrid RAG system. So with Chroma instead of like a Chroma DB, and set of APIs, like I said before. So the Chroma DB is something that like if the user wants to upload their own PDF files or any other data like PDF files, so then all the PDF files will um, collect from the Chroma DB, and then it'll provide like it will go through the LangChain and RAG, like I mean our RAG, and then feed into the LLM, like I said before. So then that means like you can upload your own PDF files, or you can use your the internal database if you want that too. Uh, so uh, so a question like like explain the top is like snipples. If I'm right, like snipples SNPs, sorry, I think explain SNPs influencing the Jiva speak and list recent papers that discuss those markers in similar environment. So then it'll go through, like I said, all the publications which is posted like late. I mean, it'll go through the latest publications. Um, yeah, so. Uh, But I want to tell you something today. Like if you are like testing the tool today, so um, we don't have option to upload the files, your files. It's not implemented yet, so it's still under development. So you wouldn't be able to upload files, but everything else is available, so you can test it. It's also it's not optimized 100%. So it's just a tool to understand. So these are the things that you can get out of this tool. So yeah, just it's a uh, so like so the first like if you so we have like a dedicated environment for the researchers to analyze their own data using RStudio, um, Jupyter Python notebook. But the problem is, I mean, the thing is that it's not implemented like I said before. So the main focus is to showcase the Emilia AI today. So these are the like the future development, future roadmaps, so that can be built. Connected to Emilia AI. Also like there's a one plan for to build an animal behavior analysis. So the reason is that I had a discussion with a researcher recently, and they were trying to mm, like annotate the data based on the video. So, like the problem is like if you have like 10 hours of video data per day, and then if you want to monitor for like a year or 1.5 years, so it's going to be a lot of data, and then you cannot do manually. So the thing is like they they were trying to use the regular tool, not the regular, like a standard tool, I would say. So which is a popular tool, I think, among those researchers. But the thing is, like, it's not like it's not updated. It's outdated software. I would say it's outdated software. So what it does is that it'll monitor on the video, and then it'll provide you a list of behaviors. So my idea is like we can integrate this into the system so that then they can upload their own videos, or then they can just give a connection to their um, cloud storage. For example, if you want like 200 days of data, like for a 10 days period, so then you might need at least 200 terabyte of data, right? And so then you cannot upload, obviously you cannot upload into our system or any other system like that. So then most of the time, then you'll have to save it to a cloud server or somewhere else, and then you can our uh, connect to our platform. So yeah, that's about it. So um, yeah, so then let's move into the Uh, demo. So thank you all for your time and attention today. So my goal is to showcase Emilia AI. So I will demonstrate our web app. If you have access to the internet and if you have a computer, please join, and then try to query or try to ask any questions, whatever you want to test. And uh, yeah, thank you. Let's go back to the platform. Here is the platform, so you can sign up. So there's like So I want to say something here. So we have a role-based like RBAC solution. That means like role-based access system. But the role-based access system is not implemented yet. So that's the proposed idea. So for now, you can just enter your like you can sign up with a regular email, or you can use a Web3 wallet. Why would you use Web3 wallet if you don't want to share your private, like if you think about your privacy, so then you wouldn't want to share your all details, right? So in that case, you can use a Web3 wallet. So then we don't keep like we keep only your wallet ID. That's it. That's what we store, nothing else. So it'll be safe if you're thinking about the data leak, or exposing your privacy like a personal data into the internet. So then it will be a good solution. Also, like we plan to add another solution which is called decentralized ID. So in that case, like we'll not keep you anything, like we'll not there are lots of protocols out there. So like we are researching on that one. So in future we'll add that option as well. So let's go. Um, Let me create. So if you have access to internet, just follow along with me. So let me create. Um, Okay, you can select any researcher. It doesn't any role. It doesn't matter right now. You'll see the same dashboard. Let me 6. So yeah. So here's the platform. I'll just walk you through the platform. So there's 3 tabs here. This one is for Emilia AI. So that's the one we are gonna demonstrate today. So the second one is the research environment. So this is the one I was talking about. It's not implemented yet, but you can see how we're gonna do. So like we can, like the user can choose which environment they want, RStudio, Jupyter Notebook, or VS Code, and then they will have like their dedicated workspace to work on their project. Uh, like Kevin mentioned earlier, for example, if you have like big data, like big data sets, so then it would be um, able to like you wouldn't be able to analyze those data in your laptop, right? Even if you know R or Python very well, but still you can do, right? So in that case, we can provide like a solution for that one. So then the users can like analyze any amount of data. So then you can scale automatically depending on their demand because we are using the AWS services underneath this one. So then it will be easier for us to manage. Of course, then you'll have to pay for your service. So if you want to use um, like big resources like big analysis kind of thing. So this one is behavior analysis not implemented yet. Okay, let me go to the chat and then let's ask like what kind of data. Let me ask like what kind of data you have. So it'll take like 20 30 seconds. That's okay. Uh, okay. Mhm. Show me the database table. So then we can ask. Just give a minute. So you'll see the animals table. So we have animal table, animal ID, um, breeds and genotype table. So yeah, so these are the available data you have. So like if you're a farmer or something, so then yeah, so the variables, health records, median pedigree, production data. So these are the table you have available today. So then you can talk to the database and you can talk to the data. You can generate like whatever you want, like so okay. So sample data from so sample what table? Production data. stay in there. Um, for some reason, I think the database failed me. So for some reason, our production web app doesn't respond with the database. I'll have to figure it out what's going on. So this is the development um, app. So you can test here as well. So then you should get the data, like say, for example, so here are the records from genetic database. So you should see the table, like animal table, then you'll get the data like this. And for see here's the breed table. So the other tables, right? So then you'll get an answer like this. And then let's see if you want to ask some questions based on uh, summarize genetic proofs in a bar chart, something. Uh, I'll do some other questions as well. Not sure why the database didn't respond this one. I'll ask another question on this one. So then, okay, here the count. Okay, yeah, here you'll see. So I create data from the database, yeah. So if you are like if you are a researcher, so if you want to do some kind of research and want to find something, so then if you ask a question like this, then it will return the latest publications and then it will retrieve all the publications from RStudio, PubMed, and Nature. So those are the three uh, public journal APIs that we have integrated for this system. Uh, Yeah, you can ask any kind of question. So there's one problem with the database response here. So I think we will have to fix that one. So it's not showing up. Let me try to graph something. So, uh, but the problem, okay, let me show you the one I already ran. So then it'll be easier. For example, here. So at the end, you should see like graph like this. So actual graph, not a sample, plotted graph, not a sample, animal stable. Okay, there's a issue with the production app, I think. So like if you want to ask any general questions that you would ask from ChatGPT or any other LLM, so you can do that one as well. You can do here that one as well. Also, we'll give you option to the users, so then they can choose whatever the model they want to use, they're familiar with, they can choose that one too. Yeah, okay, it's good now, it's working. So yeah, okay, rather than genetic database. Uh, so plot the records for me. Okay. So the problem is right now, so when you ask like a specific question, it's not handled well from the backend. So then it couldn't decide so what questions you've been the system been asked. So it couldn't decide like it couldn't decide like another which answer to respond. So that's why we are not like hard coded anything like that. So there's a like intent analyzer. So then it will analyze all of your queries. So but the ultimate goal is to create multiple agents. So then those agents will handle those kind of requests, and then eventually it will feed into the like the big Emilia AI agent. So that's the long time goal. So right now you wouldn't see that, but this is what you can see now. So the okay data generic database. So if you say generic, then it will. So these are the things like you like as a user you can get the insight out of the data. So these are the values, patterns, protein like little table. I don't know that much about genetics. So I don't know like how I mean how relevant are these data. So like for a researcher, so they would know like wow. So as a IT guy, I just like uh, wire the like the fill the gap between the tech like the IT side and the researchers. So okay, for example, plot the data. Uh, yeah. Yeah, so this is the response. I mean, this is the pretty much web app that we have today. So uh, you can try and ask any questions if you have now. Yeah, thank you.
So thank you, Gevin and Sanjeewa. So I'm going to go ahead and open it up to any questions.